You're listening to The Naked Scientists. I'm Chris Smith. If you've been on a flight recently, then there's a very high likelihood that you were carried aloft by a jet engine. These work by compressing air and squirting in fuel, which then burns, expands and generates thrust. But this also creates one of the harshest imaginable environments inside the engine, where the gas stream routinely exceeds 1500 degrees Celsius. That's well beyond the melting point of standard metals. To withstand this takes specialist superalloy components, which are produced with very high precision. And to find out how they're made, Ben Valsler's been to the casting facility of one of the world's top jet engine manufacturers, Rolls-Royce, in Derby, where he met Paul Withy.
I'm the casting specialist for Rolls-Royce, and this facility is a precision casting facility in Derby. It's Rolls-Royce's largest foundry, and it makes turbine components for large civil engines and military engines. This is one of the single crystal facilities in the world, which is one particular branch of precision casting that makes only single crystal components. And the benefit from an aerospace perspective is that if you take out all the boundaries between each of the crystals, you get the strongest possible metal that you can. And that's really needed in the hot part of the engine. So like a sugar cube, when you crush it, you actually don't break each of the individual grains, but you break the boundaries between the grains. It's the same in an aerospace metal. So we make single crystal components to get rid of those grain boundaries and have the strongest part we can.
So what's the actual process? How do you go from raw metal to jet engine part?
There's a number of different stages. If you imagine the component as not being a solid component but being a hollow component, we have to make a ceramic model of the hole we want. So we make that component called a core, inject wax around it, so we end up with a wax model of the component with the hole in the component filled with ceramic. And we take that model, we'd go into what we call the shell room, where we actually cloak it or clothe it in ceramic, and then we'll replace the wax with the metal, and then there'll be the solidification process that's the heart of this process that means we can grow a single crystal. We have to pour in a vacuum, so everything is hidden away behind steel walls.
Could we have a look anyway?
Of course, let's go.